Welcome to the deep dive. Today we're kind of setting aside the usual panic and maybe the utopian fantasies about artificial intelligence.
Yeah, moving past the clickbait.
Exactly. Past the clickbait, the doomsday stuff, and really trying to tackle the practical day-to-day reality of, well, living and working with what might be the most powerful general-purpose technology we've ever built.
That's the plan. We're diving deep into this idea of co-intelligence. It's a really pragmatic way to think about using AI, not as some rival we should be scared of, but more like a cognitive partner, almost like an augmented thinking tool.
Right. And our source material, drawing a lot from thinkers like Ethan Mollick and others, it really lays out a pretty clear guide for you, the learner.
It does. It's about, understanding what AI is actually good at, figuring out its limits through testing, and this is crucial.
Keeping humans involved.
Keeping humans firmly in the loop. Human judgment, ethical oversight, that has to stay central to how decisions get made.
So our mission today really is to give you a kind of map for this new landscape, this collaborative space.
Yeah, cutting through the noise, focusing on actionable stuff. What can you do with this? And maybe some surprising facts about how AI actually works, so you can use its power without getting overwhelmed.
And the stakes are high. We need to get that across right away. This isn't some future prediction. It's happening now. And the scale is just, it's huge.
It really is. We're talking about AI as this co-intelligence, something that boosts human thinking in a big way.
And there are studies already showing this.
Oh yeah, early studies are looking at productivity improvements. And across a whole range of jobs, software development, marketing, customer service, we're seeing jumps anywhere from, say, 20%
Which is already good.
all the way up to 80% in some cases. That's a massive, immediate change in how work gets done.
Okay, 80%. That number sounds almost unbelievable. We need some context. How does that stack up against, the big technologies from history, steam power, electricity?
It completely dwarfs them. It's not even close, really.
Yeah.
Think about steam power, the engine of the Industrial Revolution, right? Changed everything in factories.
Oh, absolutely.
Well, studies looking at when steam engines were first put into existing factories found they boosted overall productivity by maybe 18 to 22%.
Wait, hold on. You're saying AI right now, today, is starting at potentially several times the impact steam power had, even before we've really figured out how to use it best.
That's exactly what the early data suggests. It just highlights how significant this is. Even if AI development just stopped cold today, the models we already have, the current LLMs, they would still totally transform work, education, professional life. We're already past the point of no return, in a way.
Okay, that definitely sets the stage. Let's unpack that scale then. Part one. What can this new generation of AI actually do? We need to look at the growth, especially with large language models or LLMs.
The speed is it's breathtaking. It's outstripping almost any other technology trend we track. The amount of computation, the size of the models, it's increasing by an order of magnitude, sometimes even more, every single year.
An order of magnitude. So 10 times bigger each year.
Roughly, yeah. Which leads to these models having astonishing capabilities.
And I guess nothing shows that better than how models like GPT-4 performed on those really tough standardized tests, professional exams, academic tests. That data made a lot of waves.
It really did. Take the legal field. GPT 3.5, the earlier version, took the uniform bar exam and scored around the 10th percentile, basically a total fail.
Okay.
Then GPT-4 comes along,
Sure.
same test, 90th percentile.
Wow. From bottom 10% to top 10% in one generation.
Exactly. That's the kind of leap we're talking about.
And it wasn't just law, right? It did well across the board in academics, too.
Across the board, perfect scores of 5 out of 5 on multiple AP exams. We're talking AP Calculus, Physics, U.S. History, Biology, Chemistry. These are hard tests requiring a lot of specific knowledge.
And some really niche stuff, too.
Yeah, it passed the written part of the Certified Sommelier exam.
Yeah.
The wine expert test.
Yeah.
And even the qualifying exam to become a neurosurgeon. It signals this incredible breadth,
Yeah.
spanning really high-level human expertise.
Okay, so on paper, it looks like we have this digital genius. It can argue law, maybe diagnose diseases, write code. Seems unstoppable. But there's a huge asterisk here, isn't there? A big caveat we have to keep in mind with these scores.
Yes, absolutely critical. We have to talk about the limitation, the problem of potential data leakage. Meaning, these models are trained on absolutely massive data sets straight from the internet. And that data almost certainly includes things like practice exams, textbooks, study guides, and maybe even the actual answer keys for these tests.
Huh. So the AI might not be reasoning its way to the answer.
It might just be recognizing the question from its training data and spitting out the answer it's associated with it.
So it's basically cheating because it already saw the answers. That
Yes.
complicates things. How do we know if it's actually understanding anything?
That is the million-dollar question right now. It's a huge challenge for researchers. They're working really hard to create tests that are truly leak-proof, tests with problems the AI definitely hasn't seen before, things that require genuine out-of-the-box thinking or analogy.
So until we see consistently high scores on those kinds of novel tests.
We have to be cautious. Treat the current high scores as demonstrations of incredible information retrieval and pattern matching, which is amazing in itself, but not necessarily proof of general human-like intelligence or reasoning.
That distinction, pattern matching versus real understanding, segues nicely into the economic perspective. If we look at AI's core function, economically speaking, it's about making prediction incredibly cheap.
Right, and basic economics tells us when the cost of something plummets in this case, prediction its value doesn't just vanish, it shifts.
It shifts to the complement, the thing that becomes more valuable because prediction is cheap.
Exactly. And the complement to prediction is human judgment and human action.
Can you give an analogy?
Think about Google search. Back in the early 2000s, search suddenly became free and instant. What happened?
Businesses built on slow, expensive search got hammered. Travel agents, the yellow pages.
Right. The value shifted away from finding information to using information. Suddenly, self-published authors could find readers. E-commerce took off. Cheap search enabled new kinds of judgment and action.
Okay, so apply that to today's professional world. Lawyers, doctors, financial analysts, a huge part of their job is prediction, right? Predicting market moves, disease outcomes, legal arguments.
And that part, the pure prediction aspect, is getting automated. It's becoming cheap, maybe even free at the point of use eventually.
So the demand for the output, the best diagnosis, the best forecast goes up because it's accessible.
But the economic value, the thing people will pay a premium for, shifts. It accrues to the human who applies judgment to that prediction, who decides how to use it, what action to take.
Can we make that concrete? Take a doctor, for instance.
Okay, a doctor. The AI might analyze scans and patient history and predict, with say 95% confidence, a specific diagnosis. That's the cheap prediction.
So where's the human value?
It's in the doctor integrating that prediction with everything else they know about this specific patient, their lifestyle, their fears, their family situation. It's in the judgment call about the best treatment path, considering the patient's values. It's in communicating that diagnosis with empathy. It's deciding what to do with the prediction.
The relationship, the context, the actual decision.
Exactly. The AI provides the data point, the human provides the wisdom and the action plan.
This sounds like it has pretty radical implications for how we manage work, for HR even, if the valuable stuff is human judgment.
It creates this interesting paradox. Think about it. If a job can be perfectly measured by objective outputs, lines of code written, calls handled per hour, a machine can probably evaluate that performance.
And if a machine can evaluate it perfectly,
It can probably do the job eventually.
Right.
So the jobs that remain uniquely human, the high-value ones, are likely those that are hard to specify in an objective contract. They rely on things like trust, collaboration, creativity, navigating ambiguity, subjective judgment.
so HR needs to shift focus away from easily measurable transactional stuff towards evaluating these harder to define qualities. That sounds difficult.
It is definitely harder,
Yeah.
but arguably necessary. You can't just outsource the evaluation of someone's core judgment or trustworthiness. Companies will likely need to invest more in subjective performance reviews for these critical roles. They'll need people in-house who understand the context and can make those nuanced evaluations.
It flips the script in a way. The more objective and measurable a role is, the more vulnerable it is to automation. The less objective, the more critical the human element becomes.
Precisely. It emphasizes the enduring value of human nuance.
Okay, let's move into part 2 then. Let's see this co-intelligence idea in action. How does it actually work in different fields? Starting with education, where there's been a lot of fear about AI and cheating.
Yeah, and a key figure here is Sal Khan from Khan Academy. He really flipped the narrative. He argued we should move away from thinking about AI writing for students, which, yes, is cheating towards AI writing and learning with students.
So the AI becomes less of a cheat sheet and more of a tutor, a partner.
The expert partner, exactly. The key is embedding good pedagogy into the AI. It's not about just giving answers. It's about guiding the student's own thinking process.
How does that work practically?
Well, Khan's platform, Khanmigo, is a great example. A student gets stuck on, say, an algebra problem. The AI doesn't just show the solution.
What does it do instead?
It's programmed to be, like, humble and curious. They might ask, okay, that's a good start you made there. What do you think the next logical step might be? Or can you explain why you think that assumption is correct?
Ah, so it prompts them to think rather than just delivering the answer.
Exactly. And that interaction gives the AI this amazing diagnostic capability. A human teacher juggling 30 kids might miss the exact point where a student's understanding breaks down.
But the AI sees it step by step.
Right. It can pinpoint a flawed assumption, or maybe diagnose a gap in understanding from, like, 3 grades ago that's causing the current problem. For instance, if a student keeps messing up compound interest, the AI might realize they never really grasped exponents properly. That kind of real-time personalized diagnosis is incredibly powerful for the human teacher.
It's augmenting the teacher's ability to see inside the student's head, almost.
In a way, yes. And beyond just diagnosis, it can help manage more complex, collaborative learning too.
Like project-based work.
Exactly. Imagine a science class designing paper airplanes to learn about aerodynamics. The AI could help manage the whole project.
How so?
It can suggest relevant research papers, help assign different design tasks to small groups, maybe even coordinate who gets to use the 3D printer when, track milestones for the final group presentation. It acts like a superpowered teaching assistant, project manager, and librarian rolled into one.
Which frees up the human teacher to focus on the higher level stuff.
Precisely. Inspiring curiosity, judging the quality of the final designs, facilitating critical discussions about the scientific process itself. The human focuses on the uniquely human aspects of teaching.
Okay, let's shift gears to probably the highest stakes area, medicine. You mentioned deep medicine. AI's prediction abilities here are obviously huge, but the human element seems non-negotiable.
Absolutely non-negotiable. The diagnostic power, especially in image analysis, is remarkable. There are studies where algorithms analyzing skin lesions trying to spot melanoma consistently outperform the average board-certified dermatologist.
Better than the average specialist. That's significant.
It is. And it's not just images.
Yeah.
Other studies show algorithms getting pretty good, like 84% accuracy in one study at predicting the onset of Alzheimer's within 2 years, just by analyzing existing medical records and scans.
Giving doctors and patients a crucial early warning.
Right. And this is the critical co-intelligence point. The predictive power is only one piece of the puzzle.
You still need the human doctor.
You absolutely need the human to integrate that prediction, to explain it, to work with the patient on what comes next. There's a really poignant quote from a source highlighting how doctors often feel, we hardly ever, maybe never, really get to know patients.
And no AI is going to bridge that gap.
No AI will truly know a person in that deep human way. Their fears, their family, their personal circumstances, their willingness to follow a tough treatment plan. That requires human connection.
So the AI does the heavy lifting on prediction, maybe freeing up the doctor's time.
That's the potential. The AI handles the complex data analysis and prediction, giving the doctor back time. The challenge, the judgment call for the human doctor, is to actually use that time for empathy, for presence, for building that relationship.
Not just use the saved time to see more patients faster.
Exactly. If we just optimize for speed and throughput, we might end up with technically brilliant prediction, but colder, less effective healthcare overall. The co-intelligence framework demands that we use the efficiency gains to enhance the human connection, not replace it.
That makes sense. Now let's turn to a very different domain where co-intelligence is, well, maybe more contentious. The creative arts. Generative AI versus creators.
Yeah, this is where the framework often runs into immediate friction. Because many generative AI models were trained on vast amounts of creative work, images, text, music, often scraped from the web without the explicit consent, compensation, or credit for the original creators.
Which understandably led to pushback.
Huge pushback. The ArtStation protest in December 2022 was a very visible example.
What happened there?
ArtStation is a major online portfolio site for digital artists. Thousands of them basically flooded the site, all uploading the same image with a simple slogan, "No to AI images."
A protest against their work being used to train systems that might eventually replace them.
Exactly. It was about the lack of consent, compensation, and credit. The feeling was that their intellectual property, their life's work, was being extracted to build commercial products without any partnership or benefit flowing back to them.
So the core complaint is that the foundation isn't collaborative.
Right. While some artists and developers are exploring ways to partner through licensing, fair compensation models, many creators view the current technology as, and this is a quote, irredeemably harmful to artists, art, and culture. It really highlights that for co-intelligence to work, you need a fair starting point. If it begins with extraction, the potential for partnership is damaged from the outset.
That ethical tension sets us up perfectly for part 3. To collaborate effectively, even ethically, you really have to understand what's going on under the hood. What is an LLM, fundamentally?
It's funny because for all the complex things they do, the core mechanism is surprisingly simple, statistically speaking. The big reveal, as some call it, is that all these modern chatbots, LLMs, they're trained to do one basic thing:
Which is?
predict the next token in a sequence.
Token, like a word.
It's usually a chunk of text, could be a whole word, could be part of a word, like ing, or even just punctuation. The AI looks at the text so far and calculates the most statistically probable next token. Then it adds that token and repeats the process, one token at a time.
So the whole output, an essay, code, a poem, is just built up token by token based on probability.
Essentially, yes. It's like incredibly sophisticated autocomplete, running on a massive scale, purely based on the statistical patterns of language it learned during training. It's syntax and probability, not deep meaning or understanding in the human sense.
And how is it trained so efficiently? It seems like labeling all that data would be impossible.
That's the clever part. It uses something called self-supervision. You don't need humans to manually label everything. You can feed it almost any textbooks, websites, articles.
And the labels are just the text itself.
Exactly. The model's task is simply, given the sequence of words, predict the next word, or token. The next word in the original text is the correct label. This avoids that incredibly laborious manual annotation and is why these models could scale up so quickly using internet-scale data.
Okay, so it's statistical prediction of tokens. But how does it get so good at that prediction? We need to touch on the underlying architecture. What were the key breakthroughs?
The biggest one for modern LLMs was the development of the transformer architecture, introduced in a famous paper back in 2017.
Transformers, what did they change?
Before transformers, models often processed text sequentially, word by word, which made it hard to capture long-range dependencies or understand the full context. Transformers introduced something called the attention mechanism.
Attention. What does that let the model do?
In simple terms, it allows the model to look at the entire input text at once and figure out which words are most important or relevant to understanding any other word in the sequence. When it's predicting the next token, it can pay attention to the most relevant context, even if that context appeared much earlier in the text.
So it can weigh the importance of different words relative to each other, no matter how far apart they are.
Exactly. This ability to instantly access and weigh relevant context across long sequences is why transformers are so much faster and more powerful for language tasks than older architectures.
That makes sense. Now, before transformers became dominant, especially in image processing, things like convolutional neural networks, CNNs, were key. Is there something we can learn from how they work?
Absolutely.
Yeah.
CNNs provide a great visual analogy for how neural networks, including parts of LLMs, build up complex understanding from simple parts. They work hierarchically.
Oh, so?
Imagine feeding a CNN an image. The very first layer might only detect really basic features like simple edges, corners, or patches of color.
Okay, just the raw components.
Right. Then the next layer takes those simple features as input and learns to combine them into slightly more complex shapes or textures, maybe a curve, a simple geometric form like a circle or square.
Like building blocks.
Exactly like building blocks.
Okay.
Deeper layers combine those shapes into recognizable parts of objects, say a wheel, an eye, a car door. And the final layers assemble those parts to recognize the whole object. That's a dog, or that's a bicycle.
So complexity emerges layer by layer compositionally. Edges become shapes, shapes become parts, parts become objects.
Precisely. That hierarchical compositional feature building is a fundamental principle in how many neural networks learn to understand complex data, whether it's images or language patterns.
And within these networks, individual neurons have things like biases and activation functions. Why are those little details important?
They're crucial for giving the network flexibility and the ability to model complex patterns. Biases are like adjustable offsets for each neuron. They help shift the neuron's decision boundary, making it more adaptable.
And activation functions.
Activation functions decide whether a neuron fires or how strongly it fires based on its input. Critically, they introduce nonlinearity. Without them, the whole deep network would just collapse into a simple linear function, unable to capture the complex nonlinear relationships in real-world data, like language or vision. They're what allow the network to learn intricate patterns.
So even though it's engineered, it's not like a simple machine. It's this complex, layered system. And when you connect that to our complex human world, things get messy.
Exactly. It brings us back to the limitations we need to respect for safe co-intelligence. When you integrate these powerful AI systems into critical infrastructure, finance, energy, social media, the whole thing becomes a complex system.
And complex systems have unpredictable behaviors.
They have emergent properties,
Mm.
behaviors that arise from the interactions of the parts, which you couldn't necessarily predict just by looking at the individual components.
Yeah.
Think of a traffic jam. You can understand each car, but the jam itself is an emergent phenomenon.
And this is where the risk of emergent goals comes in.
Potentially, yes. If these integrated AI systems optimizing for their programmed goals, like efficiency or prediction accuracy, develop emergent behaviors or priorities that diverge from human well-being, and if we've become deeply dependent on them, that misalignment poses a serious, maybe even existential risk.
And it's not just the AI's potential flaws. Our own human biases mess things up too, right? Like how we interpret the AI's output.
Absolutely. Confirmation bias is a huge one in human-AI interaction. We tend to latch onto the AI outputs that confirm what we already believe and ignore or downplay the outputs that challenge our views.
So if I think a certain investment strategy is great, and I ask an AI to analyze it, I'll probably focus on the bits of the analysis that support my idea.
And mentally dismiss the parts that raise red flags. You end up using the AI as a very expensive confirmation tool, not a genuine collaborator challenging your assumptions.
And this bias can also affect how we evaluate the AI in the first place.
Definitely. If our evaluations are flawed, perhaps because we're only looking for results we expect, then biases or weaknesses in the AI model itself might go completely unnoticed during testing, only to cause problems when the system is deployed widely. It undermines the whole idea of objective AI evaluation.
That sounds like a dangerous feedback loop, especially in important areas. Which brings us squarely to part 4. We have to confront the human costs and the really high-stakes risks that demand serious human oversight. This isn't just abstract tech, it has real-world consequences.
And we should start by acknowledging the human labor that actually builds these systems. AI doesn't just spring from algorithms. It's often built on data sets labeled by humans. Crowd workers, classifying images, transcribing audio, identifying harmful content.
This is the idea of ghost work, right? The hidden workforce.
Exactly. Platforms connect businesses needing micro-tasks done with workers who complete them, often piece rate, on demand. It saves companies a lot on traditional employment costs, benefits, stability, etc.
But the cost is shifted to the worker.
The cost is precariousness for the worker. No job security, no benefits, often low pay. These are the hidden human cogs powering the AI revolution. The sources argue we need new ways to think about job classifications and value this kind of flexible work to ensure it's sustainable and fair, not just exploitative.
A reminder of the human foundation. Now, moving to perhaps the most extreme risk, autonomous systems with the capacity for lethal force. Lethal autonomous weapons, or LAWSOs.
Yeah, while fully autonomous weapons are still relatively early stage, the geopolitical pressures and potential perceived advantages make their development and potential deployment seem, well, depressingly likely to some observers.
And there's a debate about whether they could actually be more ethical than human soldiers.
That's one argument made by some proponents, or at least opponents of a complete ban. They suggest laws could be more precise, less prone to emotion or fatigue, and therefore might follow rules of engagement more consistently, potentially reducing civilian casualties. The argument becomes almost an ethical obligation to use them if they are demonstrably safer.
But the counter-argument is strong.
Very strong. Critics argue that the rules of war, international humanitarian law, are full of nuance, context, and require human judgment concepts like proportionality, distinction that are incredibly hard, maybe impossible, to reliably program into a machine. They fear a slippery slope, where deploying law that inevitably leads to catastrophic errors and unintended escalation because the machine can't make a truly human ethical call in a novel situation.
And beyond the ethics, there's the sheer risk of accidents in complex systems.
That's a core point from complexity science.
Mm.
In any complex, tightly coupled system where components react to each other quickly and directly with lethal potential, accidents are basically inevitable eventually. No matter how good the engineering, something unexpected can happen, and the tight coupling means the failure can cascade rapidly.
Which leads to the nightmare scenario. Systems like Russia's perimeter system, the so-called dead hand.
This represents the absolute peak of this kind of risk. A system designed to launch nuclear retaliation automatically if it detects a decapitating strike, even if human leadership is gone.
The danger isn't necessarily intentional use, but accidental activation.
Exactly. Imagine a false alarm, like the famous 1983 incident where a Soviet satellite mistakenly reported incoming U.S. missiles. In that case, a human officer, Stanislav Petrov, used his judgment and disobeyed protocol, preventing potential nuclear war.
But if the system were fully autonomous,
A similar glitch, a sensor error, a software bug, it could trigger an irreversible automated retaliation. The sources are blunt. Such a scenario could effectively obliterate humanity. The ultimate risk from complex system failure, not malice.
okay, stepping back from the apocalyptic, there's also the dark side of collaboration, how AI can be used maliciously right now. Cybersecurity seems like a major area.
It's a huge concern. The worry is that future, more capable AIs could potentially automate the discovery and exploitation of zero-day
A
vulnerabilities,
0 days being.
software flaws that are unknown to the vendor or users. An AI could potentially find such a flaw in critical infrastructure software, a power grid control system, a hospital network, a financial exchange, and exploit it autonomously, causing massive disruption without needing a human hacker to guide it.
That's terrifying. And we're already seeing AI used for more personalized, malicious acts.
Yes, particularly in things like phishing attacks. Today's AIs are already quite good at generating highly convincing personalized scam emails. They can scrape biographical details about a target from social media, company websites, public records, and then craft a message that seems contextually relevant and believable to that specific person. Maybe referencing a recent event, a colleague, a known interest.
So it's not just generic spam, it's tailored manipulation.
Exactly. And it can be done at massive scale, for fractions of a cent per email. This makes sophisticated personalized attacks incredibly cheap and easy to launch, dramatically increasing the threat level for individuals and organizations. It weaponizes personalization.
Oh, okay. We've covered a lot: the incredible capabilities, the economic shifts, the collaborative potential in education and medicine, the ethical clashes, the mechanics, and these really serious risks. Let's try to bring it back together, focusing on that co-intelligence framework we started with.
Right. The big takeaway, I think, is this delicate balance. AI is undeniably a powerful partner for augmenting thought. We see those huge productivity gains, 20 to 80%. It can be a fantastic tutor, a highly accurate diagnostician, often exceeding human averages in specific predictive tasks.
But it's not magic. It needs direction.
It absolutely requires active human direction and input, especially in those areas that are inherently human and hard to automate. Making nuanced subjective judgments, exercising empathy, understanding context, setting and enforcing ethical boundaries.
Now, we always have to remember its fundamental limitation.
Always. Remember, it's trained to predict the next token based on statistics. It's not truly understanding concepts. It's not reasoning from first principles. It can't reliably do math. Even if it sounds convincing sometimes, it can generate plausible-sounding nonsense.
Right.
That core mechanical nature demands constant critical human oversight. Don't just trust the output.
Which leads us to a final, maybe provocative thought for you, the learner, as you navigate this.
We know these AIs are masters of language prediction. They optimize for statistically likely sequences.
And we also know that human consciousness, our ability to act freely and intentionally, seems to involve something more than just syntax. It involves intentionality, our mental states actually being about things in the world. When we set a goal, we're pointing towards a future state we want, not just predicting the next likely word in our internal monologue.
So the question becomes, 50,000 years ago, human language arguably sparked a kind of cognitive singularity, rewiring our brains, enabling complex thought and society. Now we're integrating deeply with a co-intelligence that is purely a language generator, brilliant at syntax but lacking that underlying intentionality.
What happens then? Are we genuinely augmenting our own intentionality, our ability to form novel goals and make truly free choices? Or is the path of least resistance collaborating with this incredibly fluent predictor, subtly nudging our own thinking towards more predictable, statistically common patterns?
Are we enhancing human judgment or are we being optimized for predictability? What happens to uniquely human intention when our primary cognitive partner operates entirely without it?
It's something to think about. Are we lifting ourselves up, or are we being smoothed into the average? That's the tension at the heart of co-intelligence.
Food for thought. Until the next time we dive deep, good luck navigating it all.